Okay. Hey everyone. So the last stream that I did around this, I had a theory that we were going to just like do it, and then we were going to come back to a trained model, and life was going to be simple and happy and fun. As you may have guessed, based on my tone, that did not work out. And instead, we're going to try again. And it's probably going to be kind of painful, but we're going to go for it. Falcon7b, lit parrot, other friends. See how we can fine-tune falcon7b in a minimally painful way. There we go. And then we're going to save now. Great. Okay, that's live. That's live. I'm going to. Okay, YouTube is up. I want to get that other thing going. And by that, I mean my Monster Energy. If any energy drink sponsor is looking for like a really mediocre candidate to sponsor, you give me a call. I will switch energy drinks so fast you won't even know what happened. Okay, Techno Axe, royalty free music. I like their. I feel like dubstep. Ooh, okay. Actually, no, this looks really good. Oh, no, this is just one song. Alexa, turn on Holden's speakers.
Okay.
Yeah, synthwave, synthpop is good music to the end of the world. So that's great. So some other things that we're gonna do. Okay. So I've been doing some stuff to try and like make things easier. Remote git, and then other thing that we're going to do here. So there's this run remote script. It doesn't do like anything super fancy, but it mostly just like copies everything. Oh, hey, Ava. Oh yeah, here we can see this is a GitHub issue that I was looking at earlier, where someone was trying to use QLoRa and it was getting difficulties. My big problem with QLoRa, although now I do have it saving the config, sorry, I got like a whole bunch of different threads going. And actually, if we go look at our high quality run.sh file, we can see down at the bottom is like where the magic, aka the sadness, happens. And so depending on which kind of model type we're trying to train, there's a whole bunch of different tools that we can use to try and fine-tune the model. falcon7b looks really cool, except for the part where the data set seems to be hard-coded, and I'm not loving that. I could like go in and poke at it some more. I did a little bit, but regardless of what I do, it always is picking, and so that's just not so I'm gonna put that to the side for now. We'll come back to that. Lit Parrot is the one that seems like really nice in terms of its flexibility. Really good. Oh right, and then yeah. So. Yes. And so then actually what we were going to do is all of these, we're just going to get replaced with this one blurb. Holden's crappy shell scripting adventures. But you know, hey, whatever. Cool, that simplifies life a little bit, and I think we had similar logic up here, which is why I wanted to get rid of it. Yeah, okay. And we were going to swap this in as the extra index URL. And so here, let's add some comments to this. Figure out our version of Huda. So we can install the right package. Different models need different falcon7b has some issues. Right now seems to ignore our dataset param, and I'm lazy, so we'll skip this one for now. And then, okay. Lit parrot seems the happiest. Yeah. We can run our own sketchy script too. But the result does not seem to work. Does not seem to produce a fully functioning model out of the box. We might be able to copy some stuff. But IDK. Okay. Cool. These are some notes, sort of about where we are. So let's, whatever. Okay. End tokenizers. Oh, that's probably a typo in requirements, isn't it? Yeah. Okay. Oh, right. SCP git, what do we call it? Remote git. $1. Put the passwordless HTTPS config there, and that's so that we can do a pull and do our updates that way. Bloop, bloop. Okay. Okay, falcon7b. Exclude falcon7b. Exclude startup PZ2. Weights and biases. All right. What's in... I'm pretty sure this is actually empty. Yeah. What's in the ABC directory? Did we exclude lip parrot? Okay. Cool. Ignore requirements. Okay. Work on making remote. Run script less janky. Still pretty jank. Add more things to ignore. So the status makes sense. Etc. Okay. Cool. Why didn't it get pushed today? Okay. Now, what kind of machine are we using? We're using H100, so this is costing a grand total of $2 an hour. Which, yeah. Is fine. Yeah. So part of the reason why we've got all these janky shell scripts is that, like, this isn't like, we're not running this on like a real cluster. We're running this on like VMs, and they're not, Lambda Labs is cheap-ish for like the, I have a credit card level budget, but they like lack features like persistent file systems. So there's a bunch of hacks essentially in this repo to just do the setup quickly. Oh, Alexa, create a 5-minute timer. Alexa, how long are my timers? Okay, cool. Okay. Well. What was the double one? Data sets, okay. Remove duplicate. Cool. And now we'll go here. why did it not? Too used to Emacs. I would have just done the rest of the line. Okay, oh, why did that not run? Okay. Doot. Okay. Alright. Oh no, it's not dash Z. Ah, fuck. Looking good. All right. Make subsequent invocations. Alexa, stop. Are likely to need it. All right, cool. I'm gonna go put some things in the oven really quickly. I'll be right back. Cooper already put them in? Did you put the things in the oven? Thanks, Cooper. Never mind, Pooh Bear already did that for us, so we're good. Okay, and so now this is going to download some model, which we'll try and fine tune. Alright, I guess the other thing. Same for the parrot. And I'll do the same thing here inside of, because I think we're gonna have to run this again. So I'm just trying to make it so that I can do subsequent runs of my script without having to like brain really very much, because brain is not so brain. Okay, cool. Then we do this part. This part is slow. I'm not actually using torch vision, so I don't care. Two checkpoints. Okay. Now we are loading the data and making a train and test split. Oh yeah. Very exciting. Very exciting. Oof. Oh, yeah. This is done not in parallel. We could probably speed it up, but for now we just want to get things working. Yeah. Okay. Oh. I don't know what notification sound that was. But the music did stop. Okay. Test split much faster. And now we see like, hey, does the model load? Wonder where those notifications are coming from. Could be Discord, could be Slack. I don't remember the sounds. Okay. Here we go. My name is Jack. Some people think I like dogs. Okay. Yep. Oh yeah, right, okay. So are we using precision BF16 mixed? I don't remember. Let's go take a look at run.sh. Yeah, we are. Okay. Oh. Okay, and we ran out of space. So I guess we don't have enough room. Wait, what? We don't have enough room to fine-tune. We don't have enough room to fine-tune this with precision BF16 mixed. Fuck. Okay. Well, let's go take a look at fine-tune falcon7b precision lit parrot. Okay. Well, I don't know. Okay. Let's screw around with some stuff. Nope. Oh, that's so cute. That's so cool. Here, let's switch this to live mode so people can see. This is really cool. You got it from Japan, right?
Yeah, it's the company is called Colonista, and they basically make intersecting origami tessellations, but out of it's some kind of technical fabric used for sails. But you can put a flashlight inside of it. And cool, you've got a magic fairy lantern. This is cooler than I thought it was gonna be.
It's really cool.
The pine cone one isn't quite as cool as I thought it was gonna be.
Oh, I'm sorry.
But that's okay, because the pine cone one was like $20.
How much was this one?
More than $20.
I'd have to pull back.
So the pine cone one is like some dude laser cut the shapes and like you stack them on the light. But there's each one is supposed to be a little bit bigger or smaller than the one below it, except there's a spot where there's two that are the same size in a row, and that annoys me because like that's the sort of shit that yeah. And I'll set you the flashlight into half mode so it's a little bit less glowy. I like how the yellow glows. Yeah, no, I like this.
Fuck yeah.
Fuck yeah, I'm excited.
I love it. Pull back.
Love you, Queen.
Snap on.
No. Thank you for indulging.
No, it's cool. It's really cool. It looks really cool.
Cool.
Alright. So, oh, did you take the things out of the oven?
Yeah, I don't know if we're gonna be able to.
Did they get burned?
No, they didn't rise anymore.
That's okay. Snack.
They're cooling.
Snack.
I don't know how good they're gonna taste.
Snack.
No.
Snack. Okay. Yeah, okay, so with BF16 we run out of memory. Not ideal. Okay, cool. So we have a concrete loss value. That's solid. I wonder at which point it gets to not an... Okay, here we go. So, for some reason, okay, step 63, it goes to not a number, which that's really quickly. Seems weird to me, at least. Okay. Well, what happens? Let's try adapter instead of adapter v2. I don't. of it, but oh, Discord. Okay. Okay. Adapter V1 runs out of memory on an H100, which, I feel like lit para 8-bit. Okay. Lit para Q LoRa 8-bit. Finetune. I guess we could just fine tune a smaller data set. I don't love it. Well, okay. We could do this. Like, yeah. Let's try this and see if we can get this to work. And then if not, okay. Interesting question. Is this going to do the smart thing if we give it multiple GPUs? It definitely implies that it will. Let's see. Can we get $12 an hour? I'm really cheap. Ooh, or we could get 8 of them. Well, 50% more for double the RAM. Don't attach file system, because they do have file systems in some locations for some of them. But yeah, okay, let's try 8 100s. Maybe that'll work. Who knows? Okay. We'll call this one fart 1. And you are going to be 8 farts, because this has 8 GPUs. Do we have magic server box yet? No, we still don't know its IP address. The 8100s definitely take a fair bit more time to boot. Oof. Okay. Ah, we have an IP address. Fantastic. Okay. Okay. This is doing better. Well, actually about the same. Okay. At least it hasn't failed yet. So that's good. So that looks like that's working. Like, at the very least, our loss isn't becoming not a number. Which... What? Okay, cool. This is a good reminder. What? Yeah. I might do a pull-up. Is that okay? I'll do one pull-up before you hang up the rest of them. Oh, well then I can do my pull-up later, also known as never. Love you too. Okay, this looks like it's working. Very good, very exciting. Okay. Yeah, so now the thing that we're seeing here is it's trying to like talk to Magic Computer Box. Magic Computer Box, of course, does not, and by Magic Computer Box I mean our server with the A100 GPUs in it, but it's not up yet. So this is probably going to time out in a little bit, and then we'll try again. Yeah, still not working. Okay, I'm going to take this opportunity as like a quick bio break. I'll be back. I'll also do a pull-up. Well, part of a pull-up. Okay. We are back. Let's go to terminal view. Yes, we are back. Okay. Okay. That's a bug. In run remote. We will fix that. There we go. Actually, the other thing I was thinking about doing is gonna break these things up a little bit. Okay. And then over here, run remote. Transfer all of our data. Okay. Some hacks. Hacks to run faster. Mine's still going. Okay. Run that again. Here's another thing that we can do, because this is slow. Yeah. Again. What? Oh, okay, yeah. There we go. Okay. And we'll install a bunch of shit. Wait, what? Okay, so these should all just go ahead. We should be fine. Oh, okay. First run.sh. Integer comparison expected. Okay, well, we'll fix that another time. Okay. I'll free up a bunch of space quickly, and we can figure out. That was 101 gigs of caches. Okay. Other things we can do. whatever. Okay. All of this to make it go faster, and of course, it's not actually helping us, but that's okay. That's the way of our world. Oh yeah, actually, let's go take a look over here. Yeah, so this is great. I mean, the loss isn't going down, but like it's not going to not a number. So this is really, yeah, what's happening. Okay. This is very confusing. Okay, so we'll do this. And then let's do this. There could be a race condition here, which that's kind of annoying. But because we explicitly waited on the tar pit. Yeah, okay. Sync. Okay. Raise condition with TBZ2 file not being written all the way. Okay. Yeah. Whatever. Let's go ahead. And run this. Is this going to work? I don't know. Okay. So if we remember from last time, when we trained it without BF16 precision, it essentially just went off the rails around iteration number 60. And when we tried to train it with BF16 precision, we didn't have enough memory on the H1000 or 100 or whatever it is. So we've got 8 A1000s, I think. And if Lit Parrot automatically splits it up, I think we're good. That's a lot more memory. In fact, it's 8 times the memory, and even if we had 4-bit quantization, this should be sufficiently more memory for the model to fit. But if it doesn't automatically split it up, then our life is not great. And we'll have to figure out how to split it up on the different things, probably with deep speed. Or we could try doing Dolly with the A100 if this doesn't work, because the Dolly trainer ships with a deep speed config that we can just use. Okay. Okay, yeah. I'm used to running HTOP, but there's so many heckin' cores, it's actually not as useful. 0.5 NVIDIA. Okay. So yeah, we've got a lot of GPU cores with free memory, and so right now though we're still just setting up the environment, uninstalling base torch so we can install fancy new version of torch. Oh, this is the vet. I will be right back. Hello. Yeah. Okay, and we are back. We are back. There we go. We are actually back. Okay. Typo and race condition. Oh wait, no. Wait, what? Is this? Yeah. Okay. I guess actually. All right. This way we can just rerun the script in its entirety. There we go. Cool. Oh, right. Okay, that failed. Right. Okay. Okay, that makes sense. It's not actually a bug in the script. It seems to be like a fair bit behind. There we go. Okay. There we go. Download the model. Don't care about the Python image extensions. Oh, thank you for resubscribing, Taniwa. I appreciate that. Okay. But yes, here we go. I think this is still all in CPU. Yeah. But at least we're using multiple cores, right? Or we were. Okay. Now we got our data together. Are we using GPUs yet? No. Still on the CPU. And this is single threaded. Yes, I think we can improve, but as mentioned, you know, we want to get it working, and then we can try and make it go faster. Although I did spend a bunch of time trying to make it go faster, but mostly easy things that won't break stuff. Like if we change the Python code, as opposed to like the setup shell scripts, you know, it's a different department in terms of potential implications. Okay. Give it a few more minutes. Oh yeah, the news from the vet is good. Okay, so they're going to clip his whatever, the nail that got fucked up, and they're going to bandage up his paw.
Okay, good. Poor little guy.
He needs his nails trimmed more often.
He does.
It's okay. It is.
Fucked up as a mom.
It happens sometimes, you know. This is part of being a parent.
Yeah.
Oh, that's very cute.
He'll be alright.
Yeah, it's very, very cute.
Is he gonna be okay?
Yeah, they said he's fine.
Okay.
Right, like he's going to be a little uncomfortable because he's not going to like the bandage because he's a dog, but he's going to be fine.
Okay. When can we go get him?
They'll call after that's done, and then they'll probably do the shot and we can drive over.
Okay. Poor buddy.
Yep. Snuggle love. Have you had your snack? How was it? Should I make avocado toast instead? Okay. That's fine. I can deal with that. Okay. Training split. And now we produce the validation split. Hopefully we produce the validation split. Yeah, there we go. Test split, validation split, whatever. Okay, we can see it's using one GPU because it's like loading the model to run inference. Oh, here we go. Okay. There we go. Now this is where we are trying to train it. Let's see if this automatically... Ooh, okay. Devices is set to 1, but we actually have a few different devices. We might need to change a parameter. That's okay. We can do that. Let's see if it loads on more than one device or not. It looks like it's only loading on the one device. So that's probably something we need to fix. Oh, that's hard-coded. Lovely. Okay. We have 8 devices. Okay. Let's see if this will do the thing. It might not. don't actually, like, I don't know enough about fabric. Really nothing. Oh, okay, it's got a few different strategies. One of them is deep speed, and you can use deep speed to parallelize across multiple GPUs. So this very well could be using deep speed. So maybe we'll get them. No. Ah. Okay. This makes sense. Echo. That could be a very good PR though. Yeah, I think that's a good PR for the lit parrot. Project, so let's go. Alright, runs inference first. Now, it might run out of memory. We will find out. Enabling deep speed, BF16. It's not doing anything. They're all just using the CPU. Ah, there we go. Let her go. I would like to see more frequently what's going on. Okay. Weird. Why are we running C++? Okay. Whatever. Okay, the GPUs are cranking away. So that's a good sign. Okay, cool. And our loss numbers are like, not integers, floats, but they're like values that make something approximating sense. Okay, cool. So we'll probably get a model out of this. That's great. This is going to take a while, though, probably. Let's wait for it to get a little further, because we remember it went to not a number after like 60 iterations. Okay, cool. That's great. Okay, so it looks like we are finally training the model. Fuck. Okay, well, that's progress of a sort. So I think we'll get these models trained. The next thing that I need to do after this is put a bigger SSD in my desktop so I can store all of these things. And yeah, it's not perfect. It's definitely going to be kind of jank. I think actually would be the most accurate statement. But let's get a model made, and then we can try it, and we can go from there. The other thing that I do want to do, just sort of while we're hanging out here, is we've got, there's the generated LLM data. How did we generate it? I remember it's probably dataset tools, CA data, and then I guess the other thing that I kind of wanted to try is falcon7b, but you know what? Okay, I think that's good. Oh yeah, 100%. So the code is all here. It's inside of Totally Legit Co. Health Insurance LLM. The data set is a combination of things. So there's some human data, and we have that inside of here. Human data. The generated data is large, but you can generate it yourself using the cadata.py script. Yeah. And actually, yeah, so that's the other thing that I did want to try, to see if we could get like better best OSS LLM. There we go. Okay, falcon7b instruct is probably, yeah, there we go. This is the one, unless it's gotten okay, so they recommend using falcon7b instead of 7b instruct as the input. I don't actually know for sure. Falcon dash. Okay, no, we are using falcon7b, not 7b instruct. Fantastic. I'm really excited. That seems to be working. So, what was I gonna do? Oh yeah, Lambda Labs. I wish this was easier. Okay. So we're actually gonna do that. Okay, and cool. Status. Cool. So what I'm going to do here for our good friend in CA data, we're going to add okay. Cool. And then over here, git pull. Oh yeah, that's the other thing that I wanted. Okay. Oh, cool. Yeah, for sure. I mean, I'm around SF pretty much all the time. Yeah. So what I want to see here is if we can get better generated data. Because while this is running, that's the other thing that I wanted to look at. Okay, yeah, those are all the magic B ones. Oh yeah, generated. Mm-hmm. And Yeah, okay. So I think, like, realistically, we need to work a little bit on our prompt magic for our generated data set. But, like, this is not bad. And actually, I got an idea. That's a little sketchy. Um, um, mm-hmm. If not in R, do we want to rewrite these things? Kinda, yeah. Okay. Right, alpaca, def, right, alpaca, format, alpaca, still going. Okay. First alpaca. Okay. Okay. Instruction. Okay, that probably ain't gonna work. But a bit of a refactor. Yep. Okay, and so I want to compare both of these, but whatever. Okay. Like I'm thinking like a 2-stage fine tune maybe. data set tools, fine. Global. Oh yeah, okay. Oh yeah, these. Okay, cool. These looks. Train is the only one that got anything written to it. So let's go take a look. What did I screw up? Ah. Pisces. We have 9-month Cancer. Ah. Okay, so it's not none. Mm-hmm. Yeah. Okay. Python remove all stop words. Yeah. Actually, yeah, you know what? Whatever. Fuck it. I mean, well, what I'm thinking about right now. Let's go find. Yeah. To do. Remove stop words. NLTK. Python hash set. I would like to make a hash set. Preventative care recommendations, CDC. Preventative care required to be covered, USA. Cover. It's a little bit of a hack, but it gives us some more quasi-ground truth. Now this should almost be done. I'm gonna go grab the snack. I'll be right back. Hmm. Okay. So this is running. Oh yeah, let's take a look. Okay, that didn't... Oh wait, did that change? Actually, I don't know. Oh wait, yeah, I would have expected that number to increase from like 6 to 7. Oh right, no, I have to do the CP. I have to copy it over into the combined data set, otherwise it won't show up. Right, that makes sense. Okay. Here's the data. So yeah, let's write a README for the project. generates appeals to health insurance denials. How we built it. Hard to get data. While I have a fair number of health insurance denials, they aren't not super well organized. Filed a FOIA requesting appeals data from the state, but for privacy reasons, they could not share it, and they did not have a redacted version of the data set available. Thankfully, they do have the appeals decisions publicly available. So we back converted the appeals decisions into rejections and appeals and use this as a starting point. This was done using Dolly 12b. Data machines. Getting access to machines big enough to train these models is kind of tricky. While I do have some just AGXs, they don't support bits and bytes. Oh no, it's totally awesome. I'm glad you're here. Bits and bytes, so we couldn't use those tricks. Thankfully, the cloud takes credit cards. Making a website and an app. We have the start of it up at. We have the start of it. We have the start of it. Integrating the LLM into our website. Yes, for sure. Give me a second. So the source code. Now, to be clear, this source code is really jank. It's being iteratively hacked on a lot. And hi, AK. But yeah, so this code is really bad because it's exploratory code. Integrating the LLM into our website. Into our website. Getting the website deployed. Getting an app made, maybe. Improving our training data. Probably some Mechanical Turk. Collecting more denials, etc. Bits and bytes. Awesome. It has issues on NVIDIA ARM machines. Cloud is a magical saving grace. A lot of different tried Dolly, Falcon finetune. We try Dolly's built-in trainer, Falcon finetune. Parrot, and they're all what we would call works in progress. Yeah, sure. So falcon7b is a large language model. And you can use it kind of like OpenAI, but you know, it's open source, so you can see it and play around with it and do all kinds of neat things. There were a lot of different challenges. Most of them coming from trying to use the wrong hardware or tool for the job. Yes, they are very, very popular. How we built it. We combined output of multiple models, Dolly 12b, BioGPT, to generate with California's. I mean, I think they're really cool. I don't know if they deserve all of the hype, but I think there's a possibility that we can do some cool shit. Insurance data to generate a low quality synthetic data set for fine-tuning falcon7b. To generate health insurance. The appeals might not be super high quality, but if you look at the denials, I think we'll still be coding. Yeah, I think our coding will look different, but I think we'll still be coding. They're not very good either. But if you've looked at any denials you've gotten from they probably are not very sensible either. We believe that a lot of insurance companies follow a deny first approach, and they are obligated to look at appeals so we can lower the barrier to appeals. We can increase the barrier on health insurance companies to issue denials. We made a model. Yeah, I think everyone's going to Stack Overflow a lot less. Getting the website deployed, so you don't. Yeah. Okay. How are we doing? Oh, cool. We made a model. We found a creative solution to the current lack of data. Integrate the getting the website deployed, integrating with a fax API. Health insurance companies love faxes. Just deploy a machine with 8 A100s. Yeah. Okay. Cool. Cool. I haven't tried Mojo. Okay. How are we doing? The loss values are getting a lot lower. I'm liking it. And we're definitely crunching those GPUs. Get that GPU fun times. Okay, so I have a belief, perhaps unfounded. It's probably about an hour, maybe 2, until we get a model out of the other end of this. So we're gonna wrap. Oh, I have. It's been a really long time. I had to make a compiler in university. And I guess actually more recently I've been doing the Scalafix stuff, which sort of straddles the line. Like we're operating on abstract syntax trees, but we're not compiling anything really. Anyways, I think my plan is it's probably going to be another hour, maybe 2, maybe 3, before we get a model out of this. So I'm going to go and drink some coffee, call the vet, check on the dog, make sure he's doing okay, because I worry. And yeah, thank you so much for chatting, AK. Maria, and who else was there? Ava and Andromeda. It's always lovely when people show up and say hi. I really appreciate it. It's really nice. Yeah, let's see. Is there anyone who we can raid? Yeah, let's go raid Booty. So I'm gonna go listen to Booty. If you don't know them, they are on. Oh, and thank you, Taniwa, and thank you for subscribing. I appreciate that. And so yeah, I'm gonna go listen to some Booty. while our model trains and maybe do a little bit of jazzercising. So thanks, y'all. Have a good one.